Video lesson 12.2, derivatives. This is going to focus on the quotient rule. So when doing the quotient rule, first off, it's dealing with two functions, and we're going to take the denominator. It's going to multiply by the derivative of the numerator minus the numerator times the derivative of the denominator, and the whole thing's going to be divided by the denominator squared. So the formula looks like this. So the derivative with respect to x says that if I take the denominator, right, so the function would look like this. So y would equal f of x over g of x. So I have some function over another function. So the denominator times the numerator's derivative minus the numerator times the denominator's derivative, and the whole thing's divided by the denominator squared. That's the process of using the quotient rule. Now, again, could I elaborate by maybe dividing things out and simplifying and kind of elongating the process into individual terms and then do it with the power rule? You could. I could divide, for example, in this first one, I could do this process, right, and divide it out and try to get each individual term and then have an expression of each individual, like monomials, and then do that. That's a long, tedious process, especially when dealing with something as complex than the bottom that you have here, and you don't want to go through that whole thing, right? That's not really going to make it easier for us. I could rewrite it. You could go through the whole process, use the exponent rules, simplify the terms as best as humanly possible, and then get them like that. But again, there's no reason to go through all that because we have this nice little formula, right? The one thing before I go into it, you do have to be extra careful. The two things that I see students make the biggest mistakes on is, one, forgetting that you're subtracting all of this, right? Just note, you're subtracting all of this expression, okay? The other thing is that you're squaring the entire function, okay? So especially when it's something big like this, the whole function is being squared. So this whole thing is being squared. All right, so let's go through this. So my g of x and its derivative I'll do in red, and the f of x and its derivative I'll do in the blue. So in this example, this is my f of x, and this is my g of x in this example. So derivative will equal, so I'm going to do the denominator, 3x to the third plus 1, just the way it is. And I'm going to multiply that by the derivative of the top. So the derivative of the top is just going to be 4x. And I use the power rule for that. Now we're going to subtract. And again, we're subtracting all of this next part. And that is the numerator, which is 2x squared, times the derivative of the denominator. So power rule says this is 9x squared plus 0, but we don't need that part. All divided by, and again, we're going to take the 3x cubed plus 1, and that whole thing is going to be squared. All right, now all I'm going to do is just kind of simplify this and rewrite this as best as I can. Again, because I have monomials, it's an easy kind of combination here. So I've got 12x to the fourth plus 4x minus, there's no need to distribute because it's just plus 0. So it gives me minus 18x to the fourth, all over 3x to the third plus 1 squared. I'm not even going to do this one out. I'm going to leave that. But I will simplify the top since I've got this. So you're going to have negative 6x to the fourth plus 4x all over 3x to the third plus 1 squared. And that's my derivative. Let's do another example. All right. Now that one kind of simplified. It had a lot of parts going to it, but let's see how this one goes. So again, my numerator we'll do in blue here. My denominator we'll do in red. Now, if it's something for you, I know a lot of students like to sometimes do this. They might, off the side right away, just figure these two things out, the derivatives of each of the tops and the bottoms to start. And that's a great process. Sometimes, especially if they're more complex, it makes your life a little bit easier. So let's take a second, let's do that. So in the top here, using the power rule, I'm going to have 20x to the fourth plus 4x. And for the bottom, this derivative is going to be 12x to the fourth plus 0. So, in solving this, we've got f prime of x will equal, so we've got the denominator, 3x to the fourth plus 5, times the derivative of the numerator, in this case 20x to the fourth plus 4x, minus, we've got the numerator of 4x to the fifth plus 2x squared, and we're going to multiply that by the derivative of the denominator, which is 12x to the fourth. Again, all of this is being subtracted, and I'm dividing this whole thing by the denominator, which is 3x to the fourth plus 5 squared. So in this case here, not much simplifying can be done. I could distribute the 12 x to the fourth and the negative sign. So let's just make this process. Let's do that. So this, I'm just going to say leave. There's no reason to go through all of that at the moment. Since I can't simplify the entire thing nicely, just leave that part. We'll do this part though. So I'm going to have 4, that's 48, x to the ninth. And I've got plus, it'll be positive 24, but I'm going to have a negative, so negative 24x to the sixth. All over 3x to the fourth plus 5 squared. And I'm going to leave here like that. Again, I could technically simplify this process and combine all the things at the top. That would not be wrong. But in this case, for us, what we're doing right now, we're okay with this. All right. So again, go over the video, make sure you understand all the parts, make sure you, especially the formula, this is the key, right? And utilize the practice problems as a means for better understanding.